In this video, we will study about std_move, a valuable addition to the C++ language after C++11 standards. std_move is a template function that was added to the C++ language, and it helps in casting to a value reference. So after C++11, there were some additions to the language, like introduction of move assignment operator. So earlier there were just copy assignment operator. So now we have move assignment operator, and we also have move copy constructor, or rather say move constructor, in addition to copy constructor. But these functions expect R value reference as argument. So both of these. So in order to take advantage of that, you would like to convert your L value reference to R value references. So internally, you can think of this std_move as typecasting. Like if we write static cast and typecast it to whatever type you have, and then the object of type T. So if this is an L value, you can cast it back to R value reference, and you can in turn use these newly added functions. So in that way, it helps in preventing redundant copies which were created due to the creation of temporary objects. So let's see some practical examples of std_move with some running code. So let's create a few vectors. Vector of int, let's call it v1. We need to include the vector header. Now let's define a function which will print the contents of the vector. Print vector, and it will take as argument one vector of same type, int, a reference to that. Now let's add some elements to these vectors. So v1 contains elements 0 to 4. Similarly, let's do the same for v2, but this time from 10 to 14. And then print those vectors. v1, and then print vector v2, and let's see if it's working correctly till now. So it correctly prints both the vectors. Now let's see what happens when we copy vector v1 to v2, and then after copy, let's again print it. So we see that earlier there were two vectors, and now v2 also contains the elements of v1, but v1 still exists and it prints all the elements of v1. Now instead of copy, let's say we use the move on it, and then we print both these vectors. Now let's see. So till here we had two vectors, whereas after moving v1 to v2, the copy did not happen this time. There was no copy happening, and all the contents of v1 basically are now owned by v2. So we see that the call to v1 print function, it does not print anything because v1 is now empty. So in order to see that, you can also print the size of vector. So let's say add here v dot size. So we see that earlier both had 5 elements. Now v1 has 0 element because it has been moved to v2, and v2 now contains all the elements of v1. So here the copy did not happen, just transfer of resources did happen. You would be thinking that this std move has moved the resources from v1 to v2, but that's not the case. What this move does is that it converts v1 to an R value reference, and when we are assigning a R value reference to a vector, it will use the move assignment operator that is defined inside the vector class. So we will see more about this move assignment operator in my further videos. So this move can be very useful when we want to avoid unnecessary copy and we want to get rid of multiple times creation of temporary objects. So this move can be very useful, like in this case. So in this case, it was a pretty small vector, but this vector can be very huge, maybe millions of elements in that, and copying them to another vector can be a very time-consuming process. So you would like to avoid that copy and use move instead. So let's see some more applications of move semantics. So we can use this swap function using the move. Like we can define a template function swap, and here we move the contents of A to a temporary variable, and then move B to A, and then finally move temp to B. So let's see in the Xcode. So we have now move B to A, and finally move temp to B. Now let's say we want to swap those V1 and V2. And now let's run the program. So now we see that earlier V1 had 0, 1, 2, 3, 4, and V2 has 10, 11, 12, 13, 14. And now the contents have been reversed. So the copy did not happen here, just the change of the swap of actual content did happen. So we see that move can be very useful for defining even other template functions. So that's all for now. We will see the other applications of move semantics, and we will see move constructor and move assignment operators in our further videos. So see you in the next video. Thank you.